Hello, good people. In front of us, we have May 2023, Paper 2, Timezone 2, question number 4. You may pause the video first before we try to discuss it together. Okay, in this question, we have probability of 82%, which is 0.82 to be successful, and then this is done to 115 patients, and then as it is claimed that 82% is true. So question A, find the probability that exactly 90 of this patient will be cured. This is binomial situation where it can be success, it can be failed. So I will zoom out this a little bit so we have more space to work on here. Okay, I'll work on here. So question A, find the probability that exactly 90 of these patients will be cured. So in this case, we have the probability of success is 0.82. And then we have the number of trial is 115. And then exactly 90. Okay, let's just input it to our calculator. So you would like to go to binomial distribution. So second, first, here, distribution. You find binom PDF. PDF is for when we have exact number. In this case, exactly 90, yeah? Let's press enter. So the trials is 115. 115. The probability of success is 0.82. And then in this case, the X value is 90. Okay, 90 patients will be cured, and then enter. And then we got 0.0535 blah blah blah. You can just answer it like this: binom PDF 115, 0.82, 90, close bracket. I'll just write it like that. So binom PDF, forgot what was that, 115, 0.82, 90, which is equals with 0.5353. Okay, 5353 blah 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 blah, or approximately 0.0535. There you go. That will be the answer for question A. Question B, find the probability that at least 95 of this patient will be cured. If it is at least 95, meaning, question B, I'll write it like this, yeah, 94, 95, 96, 97, blah 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 blah. If it is at least 95, meaning it can be 95, can be 96, can be 97, can be blah 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 blah, up until 115. The problem is, you will see the problem in my calculator. Let me see. Second, first, we go to, in this case, binom CDF, because it is more than 1 point. Okay, so enter. The trials is 115. The P is 0.82. X value. Now, the problem with my calculator, it only calculate the one from the left, which is this one, from 0.0, 1, 2, 3, 4, 5 up until 94. So what I do is I'll just put 94, enter, and then the answer will be 1 minus whatever my answer there. Okay, so the answer will be 0.4910 blah 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 blah. Okay? Okay. Sorry. So in my case, the answer will be 1 minus binom CDF. We have 115, 0.82, 94, which is equals with What was the answer? 0.4910, 0.4910 blah blah blah, or approximately 0.491. Okay. Okay, let me repeat again. My calculator only calculate the one from the left. Here, yeah. Only calculate 0, 1, 2, 3, 4, 5, 6, 7, 8 up until 94. So the one that I need to calculate is 95, 96, 97 up until 115. So what I do is I will do 1, which is the whole probability, minus the area of 0 up until 94. That's why I use binom CDF, this one. Okay, your calculator might be different, so please ask your teacher about how to use your calculator. Okay, because your calculator might have different way to calculate it. Question C. Find the variance of the possible number of patients that will be cured. I already already copied this one. This is the formula from your formula booklet, that variance is equals with n, in this case the number of patients, times p, which is the probability, times 1 minus p. So we have variance is equals with n is the number of trial, which is 115, times the probability 0.82 times 1 minus probability 1 minus 0.82, which is equals with, let's input it to our calculator. We have 115 times 0.82 or 0.82 times 1 minus 0.82. Close bracket, enter. We have 16.974 equals with 16.974 or approximately 17.0. Okay, that's for question C. Question D. The probability that at least n patient will be cured is less than 30%. Find the least value of n. Okay, this one is a little bit challenging again with my calculator. Okay, the probability that at least n patient will be cured is less than 30%. At least n. So it means, I'll do it. Where should I do it? Let's do it here. D. Let's say we have a number, blah 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 blah. The probability of this is 30%. Okay, at least that one. At least n patient is 30%. Now, since my calculator calculate from the left, the one that I can calculate is this one instead. I can calculate this one, which is 0.7 or 70%. Okay, I'll write it 70%. Okay, here 70%. So the one that I can calculate with my calculator is the 70% one. So let's see what we got. Okay, so we go to second, first, and then we go to inverse because we are looking for the inverse binom. Enter. The area is 0.7. Once again, your calculator might have different way. So the trial is 115. The probability is 0.82. And then we paste. And then we enter. We have 97. So binom. Sorry. It's not binom. Inverse binom. Inverse binom. What should I write? 0.7. Okay. 0.7, 115, 0.82 is equals with 97. Okay. Now it means this one is start from 97. So the least possible number will be 98. Okay. Okay, let me explain again. Once again, my calculator. Your calculator might have different way. My calculator calculate from the left. So the one that I can calculate is the 70%. That's why 0.7 here. And then to get 0.7, the number goes to up to 97. The question is the least number of patient, which is 98. Okay, included in the 30%, because the 70% is goes up to 97. The 30% start from 98. So in this case, n equals with 98 patients, not 97. Okay. Next one. So the clinic want to see, is there any differences between the new remedy and then the old remedy? Okay, we have to do a t-test. So it will be 2 sample t-tests, yeah, because we have 2 sample t-tests. Okay, at the 10% significant level, E, state the appropriate null and alternate hypothesis. Okay, question E. The null hypothesis should be HO, the mu1 is equals with mu2. Remember, hypothesis for t-test is always equals, yeah? It means the old one is the same with the new one. You can also write it in words. You can say the old remedy is the same with the new remedy. Okay, that's HO. H1, the alternate hypothesis will be, wait a minute, we have to identify what is this one and then that one. Okay, cool. Okay. So before we answer this, we have to identify what is our mu1. So in this case, mu1. Okay, I'll just erase this one first. Or you know what? Let's just write it in the wording, yeah. HO. The new remedy is the same as the old remedy. Okay, once again, you can also use mu1, mu2, but you have to identify which one is mu1, which one is mu2. So I'll just do this way. The alternate hypothesis will be the alternate will be the old remedy, the new one. The new remedy is faster than the old remedy. Okay, if it is faster, or you can also say the old remedy is longer than the new remedy. Okay, cool. That will be the hypothesis. Question E, that's question E. Question F. Okay, find the p-value. Okay, let's input this to our data. Okay, this one. I did put this to my calculator data, so I don't have to do it again. Okay, so you go to start and then you edit. You input your data. I already input my data here, so you go to start again. After inputting your data, you go to test and then you pick 2 sample t-tests. Okay, and then you pick the data, make sure it's correct. Your L1, the new remedy is L1, and then your old remedy is L2. The frequency is not needed. Now this one is important. It says the mu1 and mu2. This is the alternate hypothesis, yeah. We say, take a look at your old remedy. Old remedy is in the L2. It means the L2 should be bigger than L1, or the mu2 is bigger than mu1. Okay, that's following your alternate hypothesis. So in this case, yeah, this one in the middle. Okay, let me repeat. Your new remedy is L1. Your old remedy is L2. Null hypothesis is they are the same. Okay, but alternate hypothesis, the old remedy, which is L2, taking more days than new remedy, more days. It means the mu2, this one, is bigger than mu1. That will be our alternate hypothesis. Okay, and then in IB, the pooled is always yes. Okay, it's always pooled. After you make sure that, you calculate that, and then you got the p-value is 0.062006. Okay, let's put it there. Okay. Oops. This is too small. Okay. We have p-value equals with question F. P-value. Oh, that's so bad handwriting. P-value is equals with 0.0620006. 62006 blah blah blah, or approximately 0.0620. Okay, that's question F. Question G, state the conclusion. I'll do it here. Question G. Question G, we have to state the conclusion because the alpha is equals with, what is the alpha? The confidence, sorry, what was the alpha? The alpha is 10% significance level. 10% is 0.1, 0.1, and then because which one bigger? The bigger one is the alpha, so we can say the p-value is less than alpha. Okay, so we reject the null hypothesis. Okay, you can also explain this is how many points over here. Okay, 2 marks. Okay, it will be 1 mark from here. This is your reason, and then this is your answer. Reject, it's 0. The null hypothesis. G. H. Question H. What's the question H? Explain what the p-value represent. Okay, this is the concept of p-value. P-value means the probability. The probability. You have to write it here. The probability of getting result. Of getting the result. Of getting result as observed. As observed given that the null hypothesis is true. You may write this in your own word, but basically the p-value means the probability of the getting result, the observed result, given that the null hypothesis is true. So that's it for this question. Sorry for my handwriting. This topic we need to write a lot. So if you have any comment, please leave a comment. If you like this video, leave a like. If you dislike it, just leave a dislike button. Thank you, and see you again in another video.